With this equation, cosine of xy equals x squared y squared, we're being asked once again to find y prime, to find a formula for the slope of a tangent line at a point. I've added some rules for how far we need to simplify. I want no complex fractions and no negative exponents in fractions. That's because if I had something like x to the negative 1 plus 2 over sine y or something like that, that's the same as 1 over x plus 2 over sine y. So that's really a complex fraction, just sort of written a slightly different way. Now, I often will include directions that say I don't want complex fractions and I don't want negative exponents in fractions. I won't always. I know there are times this semester where I've stopped where I had a complex fraction or a negative exponent inside of a fraction. So just make sure that you're reading directions. I might include these directions for just one particular question, or they could occur at the beginning of the exam, which means they apply to an entire exam. I tend to ask for this when we've got implicit differentiation like this, because it's possible to end up with some really, really messy answers if we're not a little bit cautious about things. So let's take a look. We're saying, okay, this equation describes some curve. No idea what it looks like, no idea whether the graph passes the vertical line test, but locally, near a particular point, if I just look at that section of graph, it's probably going to pass the vertical line test, and then this describes y implicitly as a function of x. Now again, I kind of like to put parentheses around my y's. That reminds me that y is different from x. Y is representing some function of x that I just don't happen to have a formula for. Okay. Now if I want, I can also put parentheses around the xy because that's the input to cosine. Okay, so I'm going to say if this function equals that function, they've got to have the same derivative. So the derivative of cosine of x times y equals x squared times y squared. Now here, this is a function composition, and the inside part is a product because it's x times some function of x that I just don't have an explicit formula for. So I'm going to use chain rule. Derivative of cosine of something is negative sine of that thing times the derivative of that inside part. And when I come back to evaluate this derivative, I will be using product rule. Now that's got to equal, whoops, I left out the d by dx here. I'm so sorry. I meant to take the derivative of both sides, and I inadvertently just wrote the derivative of the left and forgot to write the d by dx on the right side. Corrected that now. Okay. So this again is product rule. X squared is a function that I have an explicit formula. Y squared is an implicit function of x. So this is going to be the derivative of x squared times y squared plus x squared times the derivative with respect to x of y squared. Okay, so coming back over here, negative sine xy. I'm going to multiply that by the derivative of product rule. That's going to have two terms, so I'm going to put that in brackets. Okay, so we will have the derivative of x times y plus x times the derivative of y. And that's going to equal, here this is just 2x times y squared plus x squared. This is a function composition with y as the inside part. So I take the derivative of the squaring function to get 2y, and I multiply by the derivative of the inside part. Derivative of y is just y prime. Coming back, negative sine of xy times the derivative of x is just 1 times y will be y plus x, and the derivative of y is just y prime. Remember, I have a name, not a formula, so I have a name, not a formula for the derivative. That's going to equal 2xy squared plus, I'm going to just bump that 2 to the front, 2x squared y y prime. Okay, I think I've evaluated all the d by dx's. Let's just do our quick counting check. I see y prime 1, 2 times. I had y 2 times here. That matches. Doesn't guarantee that I did it right, but if all I've done is taken the derivative and not simplified it all, and it doesn't match, that does tell me I've done it wrong. Okay, so now I want to solve for y prime. And the problem is that y prime is paired with that y because they're in the brackets. Together, that was the derivative that I got using product rule. I want to be able to break it apart so that I can separate the pieces that have y prime and the pieces that don't. One thing I could do is divide at this point by negative sine of xy, but then I'm introducing fractions very early on. And I know with implicit differentiation, my last step is always I've got y prime times a bunch of stuff and I divide by that bunch of stuff. If I already have fractions, that's going to introduce complex fractions. Now, I could do that and then simplify the complex fraction. But I think it's simpler to break apart these brackets by just distributing that negative sign xy. As I do that, I'm going to take any variables that aren't being plugged into sine and just bump them to the front. So I would have negative y sine of xy, and then here minus x sine of xy times y prime. I generally like to put variables that aren't plugged into trig functions at the front so that I'm not likely to confuse myself and think they're part of what I'm plugging into the trig function. But I'm in the habit of always writing the y prime at the end. Doesn't matter that you do things exactly the same way I do, but I recommend that you're consistent about where you write your y prime or your dy by dx, because we're going to be looking for where are all the y primes. If I know to look at the end of the term, it makes it that much easier for me to find them. Okay, I do then need these parentheses, though, to indicate that that y prime is not part of what's being plugged into sine. Okay, so this equals 2xy squared plus 2x squared y times y prime. Okay. All right, so I think since this term's negative, I'll add it over to this side and then subtract this piece over. Could do it either way. You'll get an equivalent answer. I'm going to do it this way. So I'll have negative y sine of xy. That stays. I'm going to bump that piece over, but I'm going to subtract over 2xy squared. And then that's 2x squared y prime. And if I add that over, that's plus x sine of xy times y prime. Okay, so now every term on the right has a y prime in it. So I'm going to factor out that y prime. It's times 2x squared y plus x sine of xy. And I'm just saying that's still equal to this side here. But then if I want to solve for y prime, I just divide both sides by this quantity. So we get negative y sine of xy minus 2xy squared all over 2x squared y plus x times sine of xy. Okay, now if you'd move things over differently, you might have positives on top and negatives on bottom. That's equivalent. Just multiply by 1 in the form of negative 1 over itself, and that's what you get. Okay, so here's our formula for y prime.